First, we will start by accessing the system's software. On the desktop, you will see an icon for Lab Solutions. Double-click the icon to open the software. You may be prompted to enter a password depending on your system's security settings. Once you have the software open, navigate to the Instruments tab. Double-click on the PPSQ instrument icon to open the PPSQ analysis software. Before beginning any run, it is important to make sure that all of the LC system components are warmed up and ready to go. To do this, access the Maintenance tab in the PPSQ analysis window, then select LC Control. If the instrument is in sleep mode, you will see that the instrument parameters are set to detector and oven off, and the flow rate at 100% mobile phase B at a rate of 0.01 mils per minute for a gradient system, and PTH-AA mobile phase at 0.3 mils per minute for an isocratic system. To change these parameters, select the button with 3 dots and a data file in the drop-down menu. Since the LC parameters for each run are the same, any file can be used. Once selected, the LC control window should auto-populate with the new active LC parameters. The flow rate should change to 100% mobile phase A at a rate of 0.3 mils per minute for a gradient system and 1.0 mil per minute for an isocratic system, and the detector and oven status should switch to on. This will be 35 degrees for a gradient system and 40 degrees for an isocratic system. Select Download, then activate to transfer the command to the LC system. Once the LC is turned on, allow it to warm up for at least an hour prior to running your standard or samples. While the system is warming, you can either prepare your apomyoglobin standard in the method shown or thaw out your pre-prepared standard stock solution and dilute it to form your working solution. Next, we will load the apomyoglobin standard into a PPSQ reactor. You can access the reactors and load the apomyoglobin standard while the LC system is still warming up. To place your sample into a reactor, you will need to access the upper reactor chamber. To open the reactor block, first unscrew the top fitting connected to the reactor tubing. Second, loosen the opaque wheel at the bottom of the reactor block about 180 to 360 degrees. Then finally, fully unscrew the peak reactor block lid. You can also follow the instructions located on the underside of the lid covering the reactors on the PPSQ system. To remove the upper reactor chamber, push the toggle on the left side of the reactor block up towards the reactor block opening. This will move the set screws on the spacers that frame the reactor chambers and allow you to access and remove the upper reactor chamber and spacer. Once you have removed the upper reactor chamber and spacer, flip the chamber so that it is resting stably and upside down on the spacer. You will then see a filter holder. This may contain PTFE filters and a membrane if the reactor was used previously. Remove the filter holder and dispose of the used PTFE filter papers and membrane. We will load the apomyoglobin standard onto a PVDF membrane, which allows for good retention of proteins. Locate and place a PVDF membrane into the raised ring on the upper reactor chamber. To load the sample, first spot 5 microliters of methanol onto the membrane, followed immediately by 5 microliters of the apo working solution. The methanol will allow for more even spreading of the sample over the membrane. Wait for the PVDF membrane to dry. Place the dried membrane in between 2 PTFE filters. This prevents any gaping in between the reactor chambers and ensures that the solvents and reagents flow directly through the membrane. And then center the PVDF membrane so that it will remain fixed in the raised ring on the upper reactor chamber. Press down on the filter holder to attach the PTFE, PVDF, PTFE sandwich to the upper reactor chamber. Flip the reactor chamber and spacer and reassemble the reactor by performing the reverse steps from the disassembly. Once the system has been warmed up, navigate to the Lab Solutions PPSQ software. You will see a variety of options in the menus for each reactor. Under any reactor menu, select PVDF. Once you have selected PVDF, the following fields will appear. Sample name. Enter the type of sample, in this case, apomyoglobin, and the date. Sample ID. This is an optional field. It can be used in cases where there is a specific sample identifier to be documented. Number of cycles. This value can be a maximum of 23, which is the number for performance testing. Amount of sample in picomole. The saved folder location. The data file name. For ease, we will set this to the same as the sample name. The start number. Set this value to 1. The method file. This will need to be the latest calibration file so that the software can compare the retention times of the peaks in each cycle to the PTH-AA standard retention time. Data comments. These are optional. Register the PVDF. You will see the estimated finish time in the time schedule on the left side of the PPSQ software. Press Start to begin data acquisition. You should see the top of the schedule change to blue and read Analyzing. Once the run is finished, we can access the created .psq data file through the PPSQ post-run software. In the main Lab Solutions window, select Post-Run, then PPSQ Post-Run. When the window opens, click on the folder icon and select the most recent .ppsq data file. Navigate to the Chromatogram tab once the file is open. You should see a chromatogram reflecting a single amino acid peak, along with a couple of byproduct peaks for DPU and DPTU. On the left side of the screen, you should see the amino acid for each cycle identified by the software. This is the software's estimated sequence. You can verify that the estimated sequence matches the expected sequence for apomyoglobin by comparing the software's estimation and by navigating between different cycle chromatograms. It is important to manually compare the chromatogram peak to the chromatogram from your PTH-AA standard, which can be overlaid by selecting the button labeled STD in the Chromatogram tab, particularly when working with unknown peptides or protein samples. If the chromatograms and software estimation match the expected sequence for apomyoglobin, you have successfully verified that the system is meeting performance specifications. If the chromatograms do not match the expected sequence or low signal is observed, verify that you are using a new apomyoglobin sample and that all the solvents and reagents in the PPSQ are within their expiration dates. For further assistance, contact your local Shimadzu representative. We have now gone through the process of starting up the system and PPSQ software, loading your apomyoglobin standard, registering and acquiring your data, and verifying sequence matching and system performance. For more information about Shimadzu PPSQ instruments and related products, visit us at the link shown. Thank you very much.
Excellence in science. Shimadzu.